So here we want to sketch the graph of y equals minus 2 x minus 1 squared minus 3. Okay, so for all these problems, when you have a specific function, and you have to try to see what the parent function and the toolkit functions is for that one. Okay, so we in our toolkit we know the graphs of something like y equals x, x squared, x cubed, root of x, okay, and so on. So you have to identify which one of these functions is it in our list. Okay, so this is what I'm going to ask you to be able to do. Take a function that's in our list and perform some transformations on it. So here it's pretty clear. It's y equals x squared. Okay, now here we only need to identify what all these numbers actually do to x squared. So for example, maybe it's easier to start with these. So this is going to give us a horizontal and vertical shift. So this is a horizontal shift of 1, okay, to the right, because of it's of the form x minus h, okay, and h is positive, and a vertical shift, and a vertical shift of 3 downwards. Down. Okay, so remember I want to write it at f of a x minus h plus k. Okay, so here I don't have anything in front of x, so a is 1 here, so there's no horizontal compression at all. There's an h is 1, k is minus 3, so this is horizontal vertical shifts, and now we have to deal with this factor, okay, that stands in front of our squaring function, and that's responsible for vertical stretch or compression. Here it's a stretch because it's above 1 in magnitude, but there's a negative. So the negative actually, if you remember, right, if I've got f of x, which is x squared, if I put a negative in front, that's going to flip the parabola. So there's going to be a reflection across the x-axis. Okay, so let's do this. Okay, so here, so there's here vertical. Okay, let me spell that correctly. Vertical stretch of 2 plus reflection across about the x-axis. About the x-axis. Okay, so let's do this. Now, because the so with the reflection you have to be careful because and also because for the vertical stretch you have to be careful because the 2 here is not affecting the minus 3, right? It's only minus 2 that's multiplying x minus 1 squared. Yeah, you have to do the reflection before you start doing shifts, especially in particular the vertical shift. Okay, so so let's do that first. Okay. Okay, so we can do the minus 2x squared first. Okay, so take care of the vertical shift first. So we've got x squared, that's like that, and then maybe we can keep track of some points. So maybe 1 1 and 2 4 are on the curve. Let's see where they go. So when we multiply everything by minus 2, everything is going to be twice as far. So we're going to have 1 minus 2 here, and eventually 2 minus 8. Okay, so I can also keep track of the vertex, but near here it's not changing. Okay, and now we can do the shifts, the horizontal and vertical shifts. Okay, so try to do those actually in the end. So So here it makes sense. Like if we shift, like it means we replace x by x minus 1. We'll shift it 1 to the right, and then if we subtract 3, we're sending everything 3 units down. So the vertex will go 1 to the right, 3 down. So it's going to go in 1 minus 3. Okay. Maybe the other point, 1 minus 2, will go to 2 minus 5, you see. So something like that. Okay. Here we can actually calculate the y-intercept. When x is 0, y is minus 2, 0 minus 1 squared minus 3. So that's minus 2 times 1 minus 3. This is minus 5. So it intersects here at 0 minus 5. Okay. So I'm pretty happy with this. And maybe one quick thing to add here is there are no x-intercepts, obviously. So that means that if we were to expand this expression here and find the roots of that expression, make it everything equals to 0, solve for it using, let's say, the quadratic formula, we wouldn't find any roots. We'd find a negative underneath the square root, because if we did find roots, it means that the graph would intersect the x-axis, and it doesn't. So we can actually tell the discriminant is negative for that function.